All of you are fine. I'm Alana John, PhD scholar from the Department of Mathematics, SRM University, Andhra Pradesh. So today I am here to give a lecture on the topic circles and chords, which is a very basic and interesting topic in the NCERT syllabus, and it is useful for the students from class 9 to 12. So here I will be discussing some of the basic results regarding circles and chords and some of the prerequisites which are required for that. So let's begin. So first, we will be beginning with the definition of a circle. What is meant by a circle? So first of all, we will be discussing what is meant by a point. What is known as a point? See, here I am drawing a point in this screen. Okay. So point is nothing but it is just a dot on the plate. It is just a dot on the plate. That is known as a point. Now what I am doing? I am taking two such points on the plate. So here this is a point and this is also a point. Okay. Now I am considering all the points in between them. See, this is a point in between them. This is a point. This is a point. This is a point. Similarly, there will be many points, right? Okay. This point, this point, this point. So, if I am joined, how many points are there between these two points? There are infinitely many points. Okay. So, it is not possible to mark all the points in between them. In fact, there are infinitely many points between these two fixed points. So if I'm joining all those points between these two lines like this, then what happens? I'm joining all those points between these 2 points, then what I will be getting? Okay. Let me erase this one because the line got extended. Okay, what I will be getting? From here to here, I will be getting a line like this. Right? I will be getting a line. But this is not line, this is line segment because it is having a finite length. Right? Between two fixed points, if we are joining all the points in between them, we are getting a line segment. So what is a line segment? The line segment is nothing but it is a collection of points between two fixed points. Okay? Between two fixed points, if you are taking all the points in between them in a plane, then we are getting a line segment. Okay. Now we have line segments. Okay. Using line segments, we can construct polygons. What is meant by polygons? Polygons means the shapes which are formed by line segments, right? So here, this is a polygon which is formed by 3 line segments, right? And this polygon is known as triangle. So triangle is also a collection of points because each line segment is a collection of points. This triangle is also a collection of points. Similarly, a rectangle is also made of line segments. All polygons are made up of line segments. So these all are collection of points. Similarly, square, if you are taking pentagon, hexagon, octagon, all these are collection of points because each line segment is a collection of points. So all polygons are collection of points. Is this much clear to you? Okay. Now what I am doing? Now I will be fixing a point in the plane. Okay. Suppose I am fixing a point here. Okay, I fixed a point in the plane. Now I need all those points in the plane which are at a distance of 2 centimeters from this point. I need all those points which are at a distance of 2 centimeters from this point. Okay. So suppose This point is at a distance of 2 centimeters from the point, fixed point. This point will be also at 2 centimeters from the fixed point. This point will be also at a distance of 2 centimeters. So we need all those points which are at an equal distance of 2 centimeters from the fixed point. Then this point is also at a distance of 2 centimeters. This point. Likewise, we will be getting, see, here we will be getting many points like this here, which are at a distance of 2 centimeters from the fixed point, right? Now, if we are joining all those points which are at an equal distance of 2 centimeters from the fixed point, the shape which we will be obtaining will be like this. Okay? The shape which we will be obtaining will be like this, with the fixed point will be lying here. So what happens here, if we take any point on this shape, the distance between them will be 2 centimeters. If you are taking any point on this boundary, the distance from the fixed point will be 2 centimeters. So here the shape which we obtained is called a circle. So how we constructed this circle? We took a fixed point and then we took all those points in the plane which are at a fixed distance of 2 centimeters from the fixed point. Then we are getting a shape which is known as the circle. So what is formed by a circle? See, circle is nothing but it is a collection of all points in a plane which are at a fixed distance from a fixed point in the plane. Okay, so here in as a particular case, we were taking the fixed distance as 2 centimeters. In general, if you are taking any fixed distance from a fixed point in the plane, then the collection of all such points is called a circle. So circle is also nothing but it is also a collection of points. Is that clear? Let me erase all these things. Now, the fixed point which we took, it is having a special name, which is called the center of the circle. Okay. And now, if you are given a curve, curve means any line in this form. It is not a straight line, it is a curve. If you are giving any curve of length L, say L, of length L, then we can make many shapes using this curve, right? We can make many shapes, but we have to make a shape such that the area enclosed by it is the maximum. If someone is telling us, make a shape using this curve so that the area enclosed by the curve is maximum, then what we will, which shape we will make using this curve? Then of course the shape made by them will be the circle. The circle encloses the largest area of a given perimeter for a given length or for a given boundary length. The largest area enclosed by it will be the circle. Is that clear? So it is a speciality of the circle. So is the definition of a circle clear to you? Now we will move on to some basic definitions related to circles. So here, see, if you're taking, here say the black line joining the points A and B. So here we are taking a circle whose center is taken to be O, and we are taking 2 points A and B in the circle. Okay. Then the line joined between the points A and B, it is called a chord. So what is meant by a chord? Any line which joins any 2 points on the circumference of a circle. What is meant by circumference of a circle? Circumference is nothing but this boundary. This boundary length is known as the circumference. Okay. If you are taking any 2 points from the boundary and joining them by a line, then we will be getting a chord. Is that clear? Okay. Then this blue line joining the points C and B on the circle, it is also a chord, right? It is a line obtained by joining the 2 points C and B on the circle. But the speciality of this chord is that it passes through the center of the circle, right? It passes through the center of the circle, which means if it passes through the center, it means that it is the longest chord that can be drawn in this circle. It is the longest chord that can be drawn in this circle. So such a chord which passes through the center, hence the longest chord, it is named as the diameter of a circle. So diameter is also a chord of the circle. In fact, it is the longest chord. And also it is the chord passing through the center. So if you are taking any chord passing through the center, it will be known as the diameter. Okay. So here CV is a diameter of the circle. Okay. Now, suppose we are taking the center of the circle. Here center is taken to be O. And we are taking any other point on the circle, say the point capital E. Okay. Then if you are joining the center to the point capital E, then this line, it represents the distance from the center to the point E, right? It represents the distance from the center to the point E. And this distance is nothing but it is called the radius of a circle. So what is meant by radius of a circle? The distance from the center of the circle to any point on its circumference. So here OE is a radius, OD is also radius, OC is a radius. So if you're joining the center to any other point on the circle, then we are getting a radius. So now there is a relation between the radius of a circle and diameter of a circle. If you are taking the diameter of a circle to be of length small d and the radius of the circle to be of length small r, then diameter of a circle equal to 2 times the radius of the circle. So this is the relation between the diameter and the radius of a circle. Is that clear? The diameter is 2 times the radius. Is this these are all just basic definitions of a circle which you are supposed to know. Okay? Is this much clear to you? This is how. Next, we will be moving on to some other special definition known as an arc. What is meant by an arc in a circle? Here, suppose we are taking 2 points on the circle, say P and Q. I have taken 2 points, P and Q. Then what happens? These 2 points, it divides the circle into 2 parts. Okay, if I am taking any 2 points on the circle, then what happens? It divides the circle into 2 parts. So here I have illustrated it. See, this is one part and this is other part. So these two pieces of the circle, they are known as the arc. They are known as arc. So arc means a piece of a circle between 2 points is called an arc. It is just a piece of a circle between 2 points. So here you can see that there are 2 points. So means here there are two pieces, right? This is one piece and this is one piece. So here we can observe that one piece is smaller one and the other piece is bigger one. So the smaller one is known as the minor arc and the bigger arc, it is known as the major arc. So what is meant by an arc? It is nothing but a piece of circle between 2 points. Okay. Then if you're dividing the circle into two pieces using 2 points, then we'll be getting two important pieces, and one will be small piece and one will be big piece. Small piece is known as the minor arc and the big piece is known as the major arc. Now, if you are taking the 2 points here, that is, if the center of the circle is here, and we are taking the 2 points collinear to the center, then what happens? These 2 points divide the circle into two equal pieces. So there is no point of saying major arc, minor arc, because there both the arcs will be of the equal length. Clear? So is the concept of an arc clear to you? Okay, next, this is the results regarding triangles, which are just prerequisites here. Okay. So now we were discussing about circles, what is a circle, and some basic definitions associated with this. And now next we will be moving on to some results based on the triangles, because these are some prerequisites which we need in order to study regarding circles. Okay. So these are also some basic things which you are supposed to know. So here we will be discussing some results on triangle. So what is meant by a triangle? Triangle means it is a polygon which is made up of three line segments. So if there are three line segments, see, it's made up of three line segments. If there are three line segments, then of course, how many angles will be formed there? Three angles will be found there. So the name itself suggests triangle. Tri means three. So it makes three angles. Okay, fine. So here we'll be seeing some properties of triangles. See, one of the most important property of the triangle is the angle sum property. Huh? Angle sum property says that if we have a triangle, then of course it will be having three angles. Then, if you are adding these three angles, then the sum will be 180 degrees. That is, in particular, if you are considering this triangle, then angle A plus angle B plus angle C will be equal to how much? It will be equal to 180 degrees. Yeah. So this is known as the angle sum property of a triangle. Is that clear? Fine. So this basic property we will be using throughout in many problems, in many theorems, and also it should be by hearted. Huh? Should be by hearted, and also the concept should be clear to you. Okay. So there are different types of triangles. Okay. So here in particular we will be discussing two of them. The first one is an equilateral triangle. What is meant by an equilateral triangle? An equilateral triangle is here, the yellow one, it is an equilateral triangle. Equilateral triangle means all the three sides of the triangle should be equal. So here the mark which I have given, it shows that the three sides are equal, and also the three angles must be equal. So here the mark which I have given to the angles, it shows that the angles are also equal. So an equilateral triangle is a triangle in which all the three sides and all the three angles are equal. Then what we can say about the angles of an equilateral triangle? We know that by angle sum property, the sum of the three angles of the triangle should be 180 degrees. But here, in case of equilateral triangle, we have shown that, we have said that all the three angles should be equal, right? Then angle A should be equal to angle B and it should be equal to angle C. So all the angles can be named instead of B and C. This can be named as A itself, right? Then what will come? Angle A plus, instead of angle B, I am taking angle E first. Angle A, and instead of angle C also, I am taking angle A plus angle A. So the sum of the angles by angle sum property, it will be giving how much? 180 degrees, right? Okay, fine. And what happens? Here angle A plus angle A plus angle A. Then this can be reduced to, we can write it as triangle A, right? Okay. So this can be written as triangle A. Triangle A equal to 180 degrees. Then this 3 can be shifted here and can be divided, right? Then what happens? Then it comes 180 degree divided by 3. 180 divided by 3, how much it will be? It will be 60 degrees. So what we have proved here? We have shown that each angle of an equilateral triangle will be 60 degrees because all the angles are equal and the sum of the three angles should be 180 degrees. So divide it by 3, then we will be getting 60 degrees. Okay, so that each angle of an equilateral triangle is taken to be 60 degrees. So the next type of triangle is isosceles triangle. What is meant by isosceles triangle? Let me erase this one first. Okay. So what is meant by an isosceles triangle? Isosceles triangle, so here this violet one, it shows an isosceles triangle. An isosceles triangle is those triangle in which two sides are equal. Only two sides are equal and the third side will not be equal to that. Isosceles triangle is a triangle in which two sides are equal. So here the mark shows that these two sides, the side EF and EG are equal. And now the two properties. Here I have given two important properties. This is regarding to isosceles triangles, not at all. In general, I have stated it. But in particular, this is true for isosceles triangle. See, angles opposite to the equal sides of a triangle are equal. This is very, very important result. See, if we have two sides of a triangle which are equal, then the angles opposite to that side should also be equal. So in case of isosceles triangle, see, here I have taken an example. Here these two sides are equal, right? Then the angle opposite to this side is this one, and the angle opposite to this side is this one. So these two angles should be equal. So the angle opposite to equal sides should be equal. So in case of isosceles triangle, always we are having two equal sides. Then the angles opposite to these two equal sides should be equal. Clear? And reverse way also we can say that if two angles are equal, then the sides opposite to them should also be equal. Sides opposite to equal angles of a triangle are equal. This is also an important result. So these two results we will be using simultaneously in many problems, in many theorems and all. Okay. So is this basic concepts regarding triangles, regarding angles and properties and different types of triangles like equilateral triangle, isosceles triangle. Is the concept clear? Okay, fine. So let me erase this. Fine. So now what we are doing is when we are taking two triangles in a plane, if we are taking two triangles in a plane, then if we are taking one triangle and placing it on the other triangle, on the plane or on the surface of the other triangle, one triangle is taken and put above the other triangle, then if they fit exactly, which means no extra portions are seen outside because they fit exactly the same, then we say that the two triangles are congruent. What we say? We say that the two triangles are congruent. Okay, so what is meant by the congruence of triangle? Congruence means if you are taking two triangles and we are placing one triangle on the other, then they fit exactly. That is, no extra portions are coming outside. Then the two triangles are said to be congruent. So there are many rules to show that two triangles are congruent. We have so if two triangles are congruent, then we use this symbol to show that they are congruent. This is the congruence symbol. Okay, this one and in the above will be drawing a circle like this. Okay. So there are many rules in mathematics for showing two triangles are congruent. So here in particular, we will be discussing some of the congruence rules which will be useful for us in this context of circles. Okay. So in order to study about circles, we should need a basic knowledge regarding triangles. Okay, fine. So the first congruence rule is SAS congruence rule. What is meant by SAS? What is the full form of SASP? Side, angle, side. So this congruence rule means we are given two triangles. See here I have taken two triangles and suppose that two sides of the triangles are equal. See, here the mark shows that this side is equal to this side and this side is equal to this side. Two sides are equal. Then see, the in between the two equal sides one angle is forming, right? Here also. And if this angle is also equal for the two triangles, then we say that by SAS congruence rule, these two triangles are congruent. These two triangles are, sorry, let me go write it more clearly. Okay, we see that these two triangles are congruent. So SAS congruence rule means we need two sides to be equal and also the angle taken should be in between these two sides. It cannot be here. The angle cannot be here. This cannot be known as SAS congruence. So the angle taken should be in between the two equal sides. Then the congruence rule is called the SAS congruence rule. Then by SAS congruence rule, we can say that the two triangles are congruent. Clear? So what is SAS congruence rule? Two sides are taken to be equal and also the angle in between them are taken to be equal. Clear? Okay. So here is our first congruence rule. And the next congruence rule is ASA congruence rule, which means angle, side, angle. We are taking two angles of the two triangles to be equal and also the side in between that angle. Okay, and the side taken should be in between that angle. See, here if you are considering this example, it will be understood more clearly. Here this angle is equal to this angle and this angle is taken to be this angle. Then the side which should be equal should be the side in between these two angles. This side should be equal to this side. Then which rule we can apply? We can apply this ASA congruence rule and we can say that by ASA congruence rule, these two triangles are congruent. Is this one clear? Okay. So this is our second congruence rule. So let's move on to the next congruence rule. So here is our third congruence rule, which is SSS congruence rule, which means side, side, side. That is, in two triangles, if you are proving that their three corresponding sides are equal, then we can use this congruence rule. See here, this side is equal to this side is equal to this side, and the third side, these are equal. Then by so here the examples which I have taken, these are only particular cases. Okay. It should not be the case that it will be always that this side should be equal to this side. This side can also be equal to this side or this side. Okay. The only thing is that some side should be equal to some other side of the second triangle. Okay. So here I have taken just a particular example to illustrate the concept. Okay. Then if the three sides of a triangle are of two triangles are equal, then by SSS congruence rule, we can say that the two triangles are congruent. Clear? So now we will be discussing one more congruence rule, which is known as the RHS congruence rule. What is the full form of RHS? RHS means right angle, hypotenuse, side. So this congruence rule is used for right angled triangles. Okay. Suppose we have two right angle triangles, then of course the right angle 90-degree formed angle will be equal in between both of the triangles, right? And also, if the hypotenuse of the two triangles are equal, see, hypotenuse are equal, and any one side of the two triangles are equal. If these three conditions are there, then we can apply the RHS congruence rule, and we can see that the two triangles are congruent. So this is a symbol used for congruent. Then we can say that the two triangles are congruent. Okay. So RHS congruence rule is used for right angle triangles when the right angle, the hypotenuse, and one side of both the triangles are equal. Clear? So here we have discussed four congruence rules. SAS congruence rule, ASA congruence rule, SSS congruence rule, and RHS congruence rule. I hope these four congruence rules are clear to you. So these are all the prerequisites which we require to study about circles and their properties. Okay. So now we will be telling one more point which is important regarding the congruence of triangles. See, if we have proved two triangles to be congruent, okay, if once we have proved two triangles to be congruent, then we can say that any two sides or any two corresponding parts of the two congruent triangles are equal. Then we can say that any two corresponding parts of the congruent triangle. This is the main concept, or this is the main motivation of proving uh, two triangles to be congruent. So this is the main motivation. If we have proved two triangles to be congruent, then the corresponding parts of the two triangles can be considered equal. And in short form, we write it as CPCT. So if we have to show two sides of two triangles to be equal, then what we will do, we will first show that the two triangles are congruent. Then by CPCT, simply by applying CPCT, we will say that two sides are equal. Clear? So this is a strong concept in the congruence of triangles. Okay. So now next we will be moving on to the theorems and results based on the circles. So this much is the prerequisites which we require. Okay, so first we will be discussing the first theorem, theorem 1. So from here onwards, our main results begin. Okay, so what does the theorem 1 say? The theorem 1 says that equal chords of a circle subtend equal angles at the center. So we have already discussed what is meant by a chord of a circle. So here says that if you are taking two equal chords of a circle, so I am illustrating this theorem using a diagram. So this theorem will be clear from this diagram. So just focus here. If you're taking two chords, see here AB is a chord and CD is also a chord. Forget the remaining lines which are drawn here. Just consider these two, chord AB and chord CD. And suppose that these two chords are of equal length. Okay. Then what is meant by the angle subtended by the chord? Angle subtended by the chord at the center will be equal. The theorem says that if you have two equal chords, then the angle subtended by them at the center will be equal. How to obtain the angle subtended by them at the center? It is easy. Just join in the end points of the chord to the center by line segments. Then here join A to the center by AO, join B to the center by BO. Then we'll be getting the angle subtended by the chord AB. This is the angle subtended by the chord AB at the center. Similarly, this is the angle subtended by the chord CD at the center. Okay. So the theorem says that these two angles will also be equal. Clear? So what does the theorem 1 say? If you are having two equal chords in a circle, then the angles made by them at the center will be also equal. Okay. So here I will be providing a proof to show that this theorem is true. And the proof is quite interesting, and it will be using the concept of triangles and their congruences, which we have discussed just now. Okay. So the proof, it will be easy for you to understand. Okay. So what all are the given information? Here we have taken two equal chords named as AB and CD. So here AB and CD are two equal chords. And we are taking the center of the circle as O. Okay. So what we have to prove, we have to show that angle AOB is equal to angle COD. This is what we have to prove, right? So in order to prove this thing, what we are considering two triangles in which these two angles are involved, and then we will be proving that two triangles are congruent. Then simply by CPCT, corresponding parts of congruent triangles, we can say that these two angles are equal. So that is the concept used in the proof. So here we are considering two triangles. Which triangles we are considering? We are considering the triangle AOB and the triangle COD. Clear? So we have to prove that these two triangles are congruent. So we have four congruence rule with us, right? SAS congruence rule, ASA congruence rule, SSS congruence rule, and RHS congruence rule. So which rule here we should apply? See, what all are the given information? Here it is given that AB is equal to CD, right? It is given. So that is one condition. So this condition we have taken. Now for observe that what is this OA? OA is the radius of the circle, right? And what is OC? OC is also the radius of the circle. Clear? So we can say OA equal to OC because both are radii of the circle. Similarly, OB is the radius of the circle. Clearly, OD is also radius of the circle. So here we can say that OB equal to OD because all of them are radii of circle. Thus we got two more conditions, right? So all the three conditions which we have got is regarding sides. Side, side, side. So which congruence rule should be applied here? Yes, by SSS congruence rule, here we can see that the two triangles are congruent. Okay. Once we have proved the two triangles are congruent, then by CPCT or corresponding parts of congruent triangles, its short form is CPCT. So by CPCT, we can say that the angle subtended by them at the center, which is angle AOB and angle COD, they will be equal. So this is the proof of this theorem. So the theorem 1 says that if we are taking two equal parts in a circle, then the angle made by them at the center will also be equal. I think this theorem is clear to you, right? Okay, so let's move on to the second theorem. Here is the second theorem. What does the second theorem say? Let's see. The perpendicular from the center of a circle to a chord bisects the chord. So this is also a very important theorem. See, I will illustrate this theorem using this diagram. Just see. Suppose we are taking a chord on the circle with center O. Here we are taking a chord AB. Okay. Then what we are doing, we are drawing a perpendicular from the center O to the chord AB, which is named as OX. So this is a perpendicular. If the perpendicular is drawn, then the theorem says that the perpendicular bisects the chord. What is the meaning of bisecting the chord? Bisecting the chord means the perpendicular drawn divides the chord into two equal parts, which means that this portion AX, this portion and this portion B, these two portions of the chord will be equal. The perpendicular divides the chord into two equal parts. That is this one, AX equal to BX. This is what the theorem says. So what the theorem 2 says that if we are having a chord in a circle and if we are drawing a perpendicular from the center to the chord, then that chord bisects. Then that perpendicular bisects the chord. That is, divides the chord into two equal parts. Okay. So this is the concept of the theorem. So now let's see the proof of the theorem. So why here I am discussing the proofs of the theorem is to show you the pattern, how the theorems are proved. So this same pattern, it can be used or it can be applied in solving problems also. So this proofs will be very useful for you in order to attempt any unknown question. Okay. So what all things here, it is given that AB is a chord and we have drawn a perpendicular OX to the chord. So we have to show that it divides the chord into two equal parts. That is AX equal to BX. See? AX equal to BX. This is what we have to prove. So what we will be doing? We will be taking two triangles in which these two sides are involved, right? So I will be taking this triangle and this triangle. By just joining these points, I will be getting this triangle, right? So consider the triangles OAX and the triangle OBX. So these two triangles I will be considering. So what is the next step? We have to show that these two triangles are congruent, right? How we will show? See, here the line OX is a perpendicular, right? So this angle will be 90 degrees. Similarly, this angle will also be 90 degrees, right? So the triangles which we have taken are right angled triangles. Okay, so the first condition is that both the angles are 90 degrees. Okay. The next is the side OX. It is common to both the triangles, right? So we can take OX equal to OX. And now consider the hypotenuse of the two triangles. What is the hypotenuse? They are nothing but the radii of the circles. So of course, these two hypotenuse will be equal, right? So that also we have taken because they are radius of the circles. So which congruence rule here we can apply? Right angle, hypotenuse and one side. So by RHS congruence rule, what we can say that these two triangles are congruent. Is that clear? Once we have proved that the two triangles are congruent, then by CPCT we can say that the corresponding sides AX and PX of the two triangles will be equal using CPCT. That's all the proof of the theorem. So the proof of the theorem seems to be quite easy, right? Once you are familiar with the congruence rules of the triangles, then the proofs will be equal. Will be easy. Okay, not difficult. Okay, fine. So this is all about the theorem 2. So the theorem 2 says that if you are taking a chord and taking a perpendicular from the center to the chord, it divides the chord into two equal parts. Is that clear? Okay, so let's move on to the third theorem, theorem 3. Now what does theorem 3 say? Here, theorem 3 states that equal chords of a circle are equidistant from the center. What it says, if you are taking, so I can illustrate this theorem using this diagram. Just see, I'm taking two equal chords, AB and CD. Suppose AB and CD are two equal chords. And their distances from center, I'm taking OX, OY are the distances. OX is the distance from the center to the chord AB. OY is the distance of the center to the chord CD. So the theorem says that the distances of them from the center will be equal. If the chords are equal, then their distance from the center will also be equal. That is, OX will be equal to OY. That is what the theorem says. Clear? So the theorem 3 says that if you are taking two equal chords on the circle, then their distances from the center will also be equal. Okay? So let's see the proof of the theorem. So what all things are given? We are given two equal chords. And what we are taking, in order to show the distance from the center, the OX is taken to be the perpendicular drawn to the chord AB. And OY is also taken as the perpendicular drawn to the chord CD. OX perpendicular to AB and OY is perpendicular to CD. So we have to show that the distance of the chord from the center are equal. That is, we have to show that OX is equal to OY. Clear? OX is equal to OY. So what we will be doing? In order to show that these two distances are equal, of course, we have to consider triangles, right? and show that triangles are congruent, then by CP we can tell that these two sides are equal. So which triangles can be taken? So I will be taking C. This triangle, C, and triangle AOX and the triangle COY. Then these two distances are coming as sides of these two triangles, right? Then how can we prove that these two triangles are congruent? See, first what I will be doing. These two angles are 90-degree, right? This and this, because the line drawn are perpendiculars. So that can be taken as one condition in these two triangles. And here, the line which we have joined, AO and CO, these are nothing but, these are the radii of the circles. Then of course, they will be equal. So OA is equal to OC, which because radii of the circles, the hypotenuse. So the hypotenuse of these two triangles we have shown to be equal. Now we need to show one side is equal, right? So for that, see, that is, here we can show that the side AX, it is equal to the side CY. How it can be shown? Just it is an application of the previous theorem. See, here OX is a perpendicular drawn to the chord AB, right? Then it divides the chord AB into two equal parts. AX is equal to BX. Similarly, the perpendicular OY divides the chord CD into two equal parts, CY and DY. Okay, so CY is equal to DY. But these two chords are also equal. It is given that the two chords are equal, right? So what we can say, this CY portion will be equal to AX portion. It is given here. See, AX equal to BX. It is nothing but half of the chord AB. Similarly, CY is also half of the chord CD. But we know that the chords AB and CD are equal. Therefore, if we are taking their half, it will be also equal. So what we can say, AX is equal to CY, which means that these two sides of the triangle are equal. That can be taken as the third condition. So we have got three conditions. And the two triangles are right angle triangles. We have shown that hypotenuse equal and one sides are equal. So by RHS congruence rule, what we can say? We can say that these two triangles are congruent, right? We can say that the two triangles are congruent. Once we have proved the two triangles to be congruent, then simply by CP we can say that OX equal to OY. And this completes the proof of the theorem. So the theorem 3 says that equal chords are equidistant from the center. Equidistant means they are at the same distance from the center. I hope theorem 3 is clear to you. Okay. So now let's move on to the fourth theorem. So here is the theorem 4. So what does the theorem 4 say? See, here theorem 4 says that the length of the chord AB of a circle having radius r is given by AB equal to 2r sine phi by 2. This is just a symbol to represent the angle. Okay, phi by 2. See, this is a very strong theorem. It is giving a direct formula for calculating the length of a chord, right? It is giving a direct formula to calculate the length of the chord. So just I will be illustrating this theorem using the following diagram. Suppose I have taken a circle with the center O and the radius. Here, radius is taken to be R, and I am taking a chord AB. Okay, where AB is a chord. So what I am doing is that here the theorem says that you can calculate the length of AB if the radius R and the angle phi is known. What is this angle phi? Angle phi is taken to be the angle subtended at the center by the chord. The angle subtended at the center by the chord AB is taken to be phi. So, in order to calculate the length of the chord AB, we need to know the radius of the circle and also the angle subtended at the center of the circle by the chord AB. Okay. Then the formula is given by AB equal to 2R sine phi by 2. Okay, fine. So how it can be shown, just move on to the proof of this theorem. What first we are doing is draw a perpendicular OX from the center to the chord AB. We are drawing a perpendicular OX to the chord AB, OX. Then what happens? Then this OX divides the chord into two equal parts, right? AX will be equal to BX by theorem 2. Okay. Now I am considering the right angle triangle AXOC. This triangle I am considering. So once this perpendicular is drawn from the center to the chord AB, it also divides this angle phi into exactly half. So here, this angle, this half angle will be phi by 2. It will be divided into exactly half. Okay. So the angle will be phi by 2. Now we are considering this right angle triangle, this triangle AXO. Then what we can say, so here I'm applying trigonometry. I hope you people are familiar with the trigonometry concepts. So here I'm taking this angle and considering the sine of this angle, sine phi by 2. We know that sine will be opposite by hypotenuse, right? The equation for sine angle is opposite side by hypotenuse. So here opposite side is AX and hypotenuse is OA, which length is R. So we can write sine phi by 2 equal to AX by R. Cross multiplying. From here we will be getting AX equal to R sine phi by 2. Okay. So the length of AX is taken to be R sine phi by 2. But AX is just the half portion of the chord AB, right? So the chord AB will be twice of AX, okay? Which will be 2R sine phi by 2. Thus, we have obtained the formula for finding the length of chord AB, but this formula is valid only if the radius of the circle is known and also the angle subtended at the center by the chord AB is known. Then we can apply this formula. Is this theorem clear to you? Okay. So let's move on to the next theorem. Theorem 5. Okay. So here is the theorem 5. So what does the theorem 5 say? Let's see. Here, the theorem 5 states that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. See, here the concept of arc comes. We know what is an arc is. It is a piece of circle obtained from taking 2 points of the circle. Okay. So here it is saying that if you are taking an arc of the circle and it is subtending an angle at the center, how it subtends an angle at the center? So in particular, I will be illustrating using this diagram. I have taken 2 points P and Q, and then I am considering this arc. This is the minor arc. Okay, so here I am just considering this minor arc. Okay, then the angle subtended by it at the center is obtained by joining the points P and Q to the center O. Then we are getting the angle obtained at the subtended at the center. So this angle. Okay. So here the theorem says that the angle subtended at the center by an arc is double. It is double the angle subtended by this arc at any other point of the circle. If you are taking any other point on the circle, say capital A, then the angle subtended by the arc PQ at the angle at the point A is this one. It will be just half of this angle subtended at the center. Similarly, if you are taking a point B on the circle, then the angle subtended by the arc PQ at the angle B, it will be exactly half of this angle subtended at the center. Similarly, for the case C, point C. So this is what the theorem says. The theorem says that if you are taking an arc And then the angle subtended by the arc at the center will be double the angle subtended by the same arc at any other point on the surface. So this will be the big angle. This will be double the angle regarding to A, B, C. Okay. So here from this diagram we can say that angle POQ is equal to 2 times angle PAQ, also 2 times angle PBQ, also 2 times angle PCQ. So in fact, we can say that the angle subtended by the arc PQ on the circle, any angle subtended on the circle will be equal here. Angle PAQ is equal to angle PBQ equal to angle PCQ. But one important thing to be noted that if P and Q are joined like this, sorry, let me erase this and show you. Okay. Now, if I'm joining the points P and Q like this, from here to here and from here to here, and if I am taking the angle in between them, then this cannot be regarded as the angle subtended by this arc, because this is subtending like this. So the angle subtended by the arc on the circle should be taken opposite to this arc. Okay, this cannot be regarded as the angle. Clear? Okay, fine. So the theorem 5 says that the angle subtended by an arc at the center of the circle is double the angle subtended by the arc on any other part of the circle. Clear? So I'm not giving the proof of this theorem because it is a little bit lengthy. So you should know only the concept, what is being said in the theorem. Okay. So now, if I am joining the points P and Q here, what will happen? If I am joining the points P and Q, then I will be getting a chord on the circle, right? I am getting a chord on the circle. So the same theorem can be told for chords also. We can say that the angle subtended by the chord PQ at the center is double the angle subtended by the chord PQ on any other part of the circle. So the same theorem can be said for the chord of a circle also. Clear? This is one of the important theorems. It should be clear to you. Okay. Okay, so let's move on to the next theorem, theorem 6. This is a direct consequence of the previous theorem. Okay. In the previous theorem, we have shown that if we are taking a chord on the circle, then the angle subtended by that chord at the center will be double the angle subtended by it on any other remaining part of the circle. Right? So here, theorem 6 says that the angle subtended by the diameter of a circle at any point on the circle is 90 degrees. See, the diameter is also a chord, right? Then the angle subtended at the center by the diameter. What will be the angle subtended at the center by the diameter? It will be always 180 degree because it is forming a straight line. Okay. Then by the previous theorem, we know that any angle subtended by them at any other remaining part of the circle will be exactly half of this angle. Okay. If this is 180 degree, then the half of this will be 90 degree. So the angle subtended by this diameter on any other remaining part of the circle will be always 90 degree. This is just a direct consequence of the previous theorem. Or this theorem can also be rewritten in this form. Angle subtended by a semicircle is 90 degrees. See, if you are taking only this much portion of the circle, then we are getting a semicircle, right? Then the diameter subtends an angle 90 degree on any point on the semicircle. So this can be also rewritten like this. Angle subtended by a semicircle is 90 degree, which means that if I am joining the diameter to any point on the circle, then angle formed will be 90 degree. Is this clear? Okay. Fine. So till now we have discussed 6 important theorems, and next we will be moving on to an important concept of cyclic quadrilaterals. And this is also a central attraction in most of the problems regarding the circle. So what is meant by a cyclic quadrilateral? What is meant by a quadrilateral? Any polygon of four sides. Four-sided polygons are known as quadrilaterals, like square, rectangle, trapezium. All these are quadrilaterals having four sides. Okay. So when is a quadrilateral said to be cyclic? See, a quadrilateral ABCD is called cyclic if all the four vertices of it lie on a circle. If the quadrilateral lies inside a circle and all the four vertices of the quadrilateral lies on the boundary of the circle, if it is lying on the boundary, it should lie on the boundary, then the quadrilateral is called a cyclic quadrilateral. Is the concept clear? So a cyclic quadrilateral means a quadrilateral whose four vertices lie on a circle. In fact, it lies inside the circle and also the four vertices, it lies on the circle. Then the quadrilateral is said to be a cyclic quadrilateral. Is that clear? Okay. So now we are having an important theorem regarding the cyclic quadrilateral, which can be used in many problems. So here is the theorem, and this is our last theorem of this section. Okay. So what does the theorem say? The theorem states that the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees. Such a beautiful result regarding the cyclic quadrilateral. See, I will illustrate this theorem using this diagram. See, here we are having a cyclic quadrilateral ABCD in the circle, right? Why it is called cyclic? Because all the vertices lie on the circle, right? So here the theorem says that if you are taking the opposite angles of the cyclic quadrilateral, here angle B and angle B are opposite angles. And here angles A and angle C, these are opposite angles. Then the opposite angles of the cyclic quadrilateral, their sum, if you are summing this angle B and angle B, then we will be getting 180 degrees. Similarly, if you are summing the angles A and angle C, which are opposite angles, then the sum will be also 180 degrees. This is what the theorem says. The sum of opposite angles of a cyclic quadrilateral will be 180 degrees. It's such a simple theorem, but it is very powerful to solve many difficult problems regarding circles. Is this clear? So here we have discussed 7 important theorems, and you should revisit the theorems and by heart the concept, and you should make a note regarding the theory, what all things we have learned throughout this lecture. Okay, so it will help you. So this is our first lecture. The next lecture which we are going to conduct, it will be full composed of problems regarding the concepts which we have learned in this lecture. So you should make a brief note regarding the concepts which we have covered in this lecture. So that's all for today. Thank you for your attention and have a